Hey folks, Jim Dufault here with IO Systems in Indianapolis. In today's module, in today's training class, I wanted to take you through one of our very best selling products that IO Systems manufactures. It's the IO Systems Tempstat and the IO Systems Concealostat. So the IO Systems Tempstat, as the name implies, it is a temporary thermostat to be used in construction type applications, but we also manufacture this in a Concealostat type option, and basically what this means is we're putting a Tempstat and we're concealing it behind a stainless steel cover for applications where it's going to be mounted permanently, like in a warehouse or a gymnasium, hallway, that type of thing. So I wanted to take you very quickly through some of the features and the benefits of the IO Systems Tempstat, and then take you through some of the applications that these can be used for, and a little bit about the wiring and getting one of these hooked up and ready to go. So to start off with the features and the benefits of the Tempstat, one thing that we always want to let you know is that this is the original Tempstat. We have the patent on Tempstats, and we want you to know that because these are unique compared to other ones that might be on the market. For one thing that we do with the IO Systems Tempstat, when you pull off the cover, is you're going to notice a capacitor that we wire and into the two leads on this. So I've got a camera set up on my right, your left, just to give you a quick glance at it, because I know it's probably hard to see the little capacitor that's on this. But if you look over here, you're going to see down below that we've gone ahead and we've wired a capacitor in. Now, the reason why we do that is a capacitor actually eliminates arcing. So now, if we were able to actually look on the inside of this little Tempstat, and I've got a graphic that's going to come up for you that's going to give you a little better glimpse on the inside of this. We've got two contacts. They're bimetal, and what these do is they're very sensitive. Being bimetal, they're sensitive to temperature swings, and as they move back and forth and get close enough, they go ahead and close. So what happens when those contacts get close enough and begin to close, there's arcing that can take place in between those two contacts. So what we're wanting to do is eliminate that. Now, arcing does two things. Arcing creates heat, obviously, and because we don't want to have heat going on inside an actual Tempstat, a type of thermostat, because we don't want short cycling happening. So that's one reason we use the capacitor. Number two, arcing is going to go ahead and degrade the contacts that are in there, and that's going to actually reduce the life of the Tempstat itself. And so when we're able to tell you that these will last as long as a regular thermostat, we absolutely mean it. So that's the capacitor in a nutshell, and part of the patent that we have on these. Now, when we do manufacture these, we actually test these 2 to 3 times to make sure that the tolerances are in spec. So when we tell you it's a 70-degree heating Tempstat, we are as close to 70 degrees as we can possibly get. So we test these multiple times before we send them out to make sure that they're within that tolerance. We actually go through about 20 to 25% of these we actually pitch. They don't make the cut. They're not within the tolerances that we like, which is around 2 to 3 degrees maximum to make sure. So particularly in an application like we make a 41-degree Tempstat. Well, you can't have a large variable in swing because now we're getting close to the freezing temperature. And we want to make sure that when it's a 41-degree Tempstat, it's a 41-degree Tempstat. So the tolerances on these are extremely tight. Now, aside from the multiple testing, one other thing is these the wires themselves. These are non-polaric, and all that means is there's not a positive and there's not a negative wire. So we're not worried about which one is going to go to one. So if you're in a heating type application, you're going to be wiring one into the R wire, and you're going to be wiring the other one into the W wire. It's just that simple. So you're not having to worry about which one goes with the other. So now we do make these in multiple type heating and cooling. So I've got a packet here. Now we do sell these in packets of 10, just so that you know. These are heating, and then of course we also do cooling. And we have multiple temperature ranges in both. With the heating Tempstats, we go all the way down to, again, a 41-degree Tempstat, and that's really for structures that you're just really not wanting something to freeze. So it's pretty much going to be unoccupied at that point. And then we go up to a 60, a 65, a 70, and even a 75 in heating. And then on the cooling side, we go all the way down to a 55-degree cooling as a compressor lockout feature. And then we go up to 80 degrees worth of cooling on this side. So we do have multiple temperatures that you can use, and we also do that in the Concealostat as well. So again, for a permanent type application, and you can even use these smaller ones for a permanent type application as well. So now, moving on, we want to make sure that these not only last as long as a regular thermostat, but that's the reason why we go through all of the testing that we do. That's the reason why we've added the capacitor to these, and they're designed to save the contractor money. So think of it this way. You know, when you're looking at something as inexpensive as a temp stat versus actually a contractor putting in a real thermostat into a structure that can, number one, it can be lost, it can be damaged, it can be stolen, but more importantly, it can be tampered with. So we want to eliminate the ability to have say a subcontractor or anybody just coming into the structure that's under construction or anywhere and going ahead and turning up or turning down the temperature on the thermostat, doing the work that needs to be done in the structure and then leaving, and the AC is running or the heat is running and it's raising the contractor's electrical bill. So we want to help eliminate that, and that's really what a temp stat does. So, and moving on, I want to take you now through some of the applications and some of the wiring that goes along with these. So, you know, we get asked questions all the time, fairly typical questions, and I want to take you through a couple of those. But for the most part, when you're looking at wiring one of these in a heating type application, again, one is going to go to the R wire, and then the other one is going to go to the W for a heating type application. Now, if you can obviously use the cooling ones and the heating ones when you have, say, a compressor, and you're going to be wiring in that. So let me take you through just two of the questions that we typically get, and they're really going to help answer the questions that you're probably having now about the wiring of these. So very quickly, two of them that we get obviously is, how is a temp stat wired? Well, very simply, it's connected between the W and the R terminals, just as if we were using a regular heat-only type thermostat. And the other question that we always get is what is the temp stat, or how is a temp stat rather, wired when in use with a heat pump? So the answer to that, typically the resistance heat is operated during construction. Therefore, the temp stat should be wired across the W and the R. And of course, depending on the equipment, a jumper may be required between the W and the G at the air handler to help control the fan. Now, if the compressor is to be used for temporary heat, simply wire across the Y and the R. Of course, assuming that the changeover valve is energized, you know, for a call in that respect. So that's kind of the wiring in a nutshell. So it is fairly simple. These are 24 VAC, so these are low voltage type application temp stats. However, if you're using the conceal-a-stat, again, in a permanent type application like in a warehouse or whatever, you can actually wire these with line voltage. However, you are going to need to add a relay that's going to go along with that. And of course, we sell these in both 115 and 240 VAC, so that you've got a relay that'll actually work with the line voltage that you're using in the structure. So you can permanently mount these. So that's pretty much it for the I/O Systems temp stat and the I/O Systems conceal-a-stat. That kind of takes you through, you know, some of the things that you need to know about the temp stat itself. So just to recap, you're looking at a patented design. Nobody makes these like we do, all right? This is the absolute original temp stat. We add a capacitor to these to prevent arcing. And again, arcing creates heat, which creates short cycling, which we don't want. Arcing also degrades and takes down the long life of the temp stat itself. We don't want that to happen. You can use these as a regular thermostat, or they'll last as long as a regular thermostat. So there are multiple heating and cooling options for these. So depending on the part of the country that you're in, you have that ability. So, and also, when we tell you that these are long life and that you can use these, here's a couple applications that you may not normally think of when you're wanting to use a temp stat. So you can actually wire these in series and use these with an actual thermostat. So think of it like this. If you've got, say, an apartment complex, or you're wanting to control somebody manipulating the set point on a thermostat, maybe they don't pay for heat in the apartment or the complex that they're in. You can wire say a 70-degree temp stat, and you can wire that in series between the thermostat and the HVAC equipment using the W wire, and you'll wire that in series. And what that will do is they can take the actual thermostat that's on the wall and crank that thing up to 95 degrees. It's not going to go over the 70 degrees that this temp stat is wired to do. So they may think, and the thermostat's going to show that they're going to 95 degrees, but the heat won't go any higher than 70. Now, conversely, you can say take a 60-degree heating temp stat, and you can wire this in parallel. So now we're going to wire it into the W, and we're going to wire it into the R wire between the actual thermostat and, again, the HVAC equipment. So this is how unique this is. So in the event, particularly say in northern climates where freezing can be an option, in the event that somebody either shuts off the thermostat completely or the thermostat becomes damaged or inoperable, this is still going to work. And if the heat, or rather if the temperature in the structure gets below 60 degrees, because this is a 60-degree temp stat, it's going to go ahead and kick the heat on, and it's going to keep the structure from possibly freezing, pipes from freezing, water breakage, and all that good stuff. So just another great application for the I/O Systems TempStat. They also save a great deal of money, and they can be used again in a permanent type application. So that wraps up the I/O Systems TempStat and the I/O Systems Conceal-A-Stat. I hope you've gotten something out of this today. We appreciate you watching this training module. I'm Jim Dufall for I/O Systems. Thanks for watching.